So how do we set up the problem for calculating the amount of pennies that your boat can hold? The first thing you want to remember is free body diagram wise. Here is my boat in the water. We have it right at that level where it's full of pennies. Now you got to look at forces. So what forces are acting on this? Remember, we have a buoyant force. We have an F of G. Now, the F of G is the weight, and what is the weight of? Well, we have both the weight of the boat, which you should have recorded the mass of the boat in grams. Make sure you convert that, because then when you can go through, we take the mass of the boat in kilograms times G. That will give us the weight of our boat. And don't forget, we also have the F of G of my pennies. Now, this is what I'm solving for. I'm going to solve for the F of G of pennies. Now, in class, when we did the penguin problem, this is just like the penguin problem in class. So when you go through, we set it up yesterday where we solve for the total mass of penguins. You can solve for the total weight of the penguins. We could solve for F of G or the mass. It doesn't really matter. So we're trying to figure out, this is the total weight that my boat can hold, the total F of G that my boat can hold. Now, up in the problem, it lists what the mass of a penny is. So when you're done, you either solve this for the total mass of the pennies or the total weight of the pennies. I don't know. You have two choices. Then what you're going to do is you have your total FG of your pennies, and in order to do that, we have X number of pennies. That's the number of pennies that your thing can take, times the FG of 1 penny. Okay, it's just like the penguin one. You could have solved for the total mass here, and if you solve for the total mass, then you're going to divide by the mass of a penny to determine the number of pennies. Should be 30-ish, 50-ish. Some kids every now and then get into 60s and 70s. It should be close to what you got in the tank in the back. If it's way off, you did something wrong. Remember, this is the density that's being displaced times the volume that's being displaced times G. What's being pushed out of the way? How much is being pushed out of the way? This volume of water that's being displaced is the same as the volume of your boat. Your boat sank, your boat displaced some water, it displaced that much water before it sank. In cubic meters. Make sure you did that conversion ahead of time.